Hello and welcome to Lecture 3 of Chemistry for Nursing Students. In this lecture, we are going to go over electron arrangement and the octet rule. What is the octet rule? The octet rule refers to the fact that atoms are the most stable when they have 8 electrons in their outermost shell. So it's basically the tendency of atoms to have 8 electrons, so octet means 8, in their outermost shell. Because that is how they are the most stabilized. And if you recall, we said outermost shell is the last energy shell around the nucleus where it is occupied by the valence electrons. Okay, so electron arrangement. What are these? N equals 1, N equals 2, and N equals 3. We are going to look at these through an example. Let's say we want to look at the electron arrangement for fluorine atom. So fluorine has atomic number of 9, so it's 9, and we write the atomic number down below here. So it has 9 protons, and in the neutral form it has 9 electrons as well. So this is N equals 1, that is occupied by 2 electrons. On N equals 2, N equals 2 can hold a maximum number of 8 electrons. So this is 2 electrons. Fluorine has 9 electrons in total, so 2 on N equals 1, and on N equals 2 we have 7 electrons. So to have 8 electrons in its outermost shell, fluorine binds with other atoms of other elements, or another fluorine. So basically it participates in formation of compounds in order to reach its full octet. So this is N equals 2 for fluorine. We don't go above N equals 2 because of the number of electrons that it has, but if you go down the column, there are more and more energy shells they are added, which are going to be occupied by more electrons. N equals 3 can hold a maximum number of 18 electrons. Okay, so if you recall again from the previous lecture, the red section, the right part of the periodic section is mostly non-metals, and the blue portion is metals. Non-metals, to reach their full octet, they gain electrons, and the metals, to reach their full octet, they lose electron. We're going to need this concept when we go over ionic compounds. So we have two different kinds of compounds. We have molecular compounds and we have ionic compounds. We are going to go over molecular compounds or covalent compounds later. First, we're going to go over ionic compounds. So ionic compounds is when a metal reacts with a non-metal. Reacts with a non-metal. So cation is basically the metal atom that has lost electron or electrons and is positively charged. The anion is the non-metal atom that has gained electron and is negatively charged. So metals always lose electron, and as a result they become positively charged. Non-metals, they gain electron in a compound when they react to become negatively charged. And specifically here we are talking about ionic compounds. We're going to see how non-metals behave when they are in molecular or covalent compounds. Isoelectronic. Isoelectronic means the same number of electrons, and it basically refers to atoms of different elements that have the same number of electrons. For example, nitrogen, so this is the first column, this is second, third, fourth, fifth, sixth, seventh, and eighth. So nitrogen belongs to the fifth column. It has 5 valence electrons. To become full octet, it needs 3 electrons. And when it gains 3 electrons, it becomes negatively charged. So it becomes N3 minus. So now, after it has gained 3 electrons, it has a total of, so it has 7 in the neutral form, and plus these 3 additional electrons that it has received, it has a total of 10 electrons. Neon is right here, is on the second row, and it's a noble gas. This column, the 8th column, are called noble gas. So they have their valence shell completely full. That's why they have no tendency to participate in reactions to form compounds. Neon has 10 electrons. So these two different atoms belong to different elements. They both have 10 electrons, and we call these isoelectronic species. Okay, so we are going to, as an example, go over binding in NaCl and see how each of these atoms basically how many electrons they lose and gain, and basically what happens to them. So sodium has an atomic number of 11, so it means we have 11 protons. On the first energy shell we have 2. On the second one we have 8. And on the last one we have only 1. This is sodium in the neutral form, in the form that it has not reacted yet. Chlorine, it has an atomic number of 17. So this is 17 protons. First energy shell is 2. Second is 8. And the third one, so 2 and 8 is 10. The last one is 7. 6 and 7. So actually I'm going to use color red to show the last electron on sodium. So like I said, this is before they have reacted, and after they react, sodium is going to lose the last electron that it has So it's the shell right below that is going to be completely full. It's going to be full octet. So Na plus, the number of protons does not change. So here is 2, and the next one is 8. So this is Na plus. It lost the sole electron that it has is in outermost shell, and chlorine is going to receive this electron. So I'm just going to copy paste here. This is Cl minus